as a final point to make is that if you have a periodic function, for instance, like the sine, let me erase this. So something like the sine, right? This is clearly not injective, right? But because, well, if, for instance, the value 1 is repeated infinitely many times, okay? So how do we define an inverse for this? Well, typically what we do is we restrict an interval where it is injective in the case of, so this is the sine, okay? In the case of the sine, we take from minus pi over 2 to pi over 2, okay? And we know that when the sine is pi over 2, this is 1, and then this is minus 1. So this goes like this, well, something like that, okay? If I learn how to paint correctly. Okay, you see? So this, in this interval, the sine is, this is sine of x. This is injective, okay? So then you can define a function that's the sine, the inverse of the sine, that we normally call the arc sine of x, okay? And this is a function that is defined in minus 1, 1, and it goes to pi over 2 from, so this is pi over 2, and this is minus pi over 2. So it's kind of similar in a sense, but it does something like this. Let's see. It does something like this. Okay, this is the arc sine. Okay, so it's only defined in this interval minus 1, 1. Okay, and it goes from minus pi over 2 to pi over 2. You could also take any other part where the sine is not is injective, for instance, from, let's see, 3 pi over 2 to 5 pi over 2, for instance, or from pi over 2 to 3 pi over 2, right? So in that sense, you would get different definitions of the inverse, but the standard way is to define it in this interval from minus pi over 2 to pi over 2. Okay? You could do the same thing with the cosine. Okay, so the cosine, let me, for instance, here, the cosine goes like this, and then like this. Okay, so this is the cosine. Typically, for the inverse, what we choose is the interval from, this is pi, and this is pi over 2, right? We choose the interval from 0 to pi, right? And so again, we have a function that's defined between minus 1 and 1, because this is the range of the cosine in that interval. And then, as I told you, the rule to get the inverse is to mirror the function with respect to this y equals x line. Okay, so in this case, this starts at 1. When we should start at 1, something here. I painted this terribly, but the idea is you have this, and then it would go like this, and then something like that. Okay, so if you paint it here, just like I painted the inverse sine, this is from minus 1 to 1. So this is pi when it's minus 1, and then this is pi and then 0, okay, as I told you. So it's something like this, okay, something like that. Okay, so this is the arc cosine of x, or the cosine inverse. Okay, but because of the fact that the sine and the cosine are actually shifted functions, and we're taking only one part of the function to derive its inverse, the two inverses are related actually. So the arc cosine of x is just pi halves minus the arc sine of x. Okay, and so you can see that when the arc sine is growing, the arc cosine is decreasing, and then this starts at pi and this starts at minus pi over half. So this is a good definition. And finally, you can do the same with the tangent, for instance. Okay, so remember that the tangent is this function that, you know, if this is minus pi over half, okay, minus pi over 2, and then this is minus plus pi over 2. Then the tangent of x goes like this. It goes from minus infinity, goes to 0, and then goes like this. Okay, if I learn how to paint correctly. Well, the arctangent, which is the inverse of the tangent, it has the domain. Okay, the domain of this, the range of the tangent here. We usually take this interval. The range of the tangent here is the reals. Okay, this goes to minus infinity, this goes to plus infinity. So the domain is the reals. It goes to 0 at 0. Okay, so let me write, sorry. Let me write a line here. And it has two horizontal asymptotes at pi over 2 and minus pi over 2. And it does something like this. Okay, so if you do the trick y equals x, you will see that this is the function. Okay, so this is the arctangent of x. Have it in mind, because the arctangent appears a lot, especially in integrals and many other exercises that we will do during the course. Okay, so one last thing about inverse functions is that remember that the inverse of a function is not the same as the how to say this, the reciprocal of f, okay, which is, this is 1 over f of x. Okay, the reciprocal is not the same as the inverse. Okay, so for instance, in the sines, if f of x is the sine, then the inverse is the arcsine, and the reciprocal is 1 over the sine of x, which are not the same function. Okay, and this is the cosecant of x, right? Okay, and so finally I'll leave you with two exercises, or well, one exercise with two parts. First, I want you to argue that the hyperbolic sine has a unique inverse, and so think about why it would be the case, and this is the formula for it. And then the function, the hyperbolic cosine, has two inverses. Why is that? And that's those are the formula for the two. And the hint is to solve this equation, transforming it into a second order equation where you can write z equals e to the y. So this is z squared minus 2xz minus 1 equals 0, and then you can solve it and then take logarithms. And similar procedure for hyperbolic cosine. And can you find an expression for the hyperbolic tangent? Okay, so that's the end of Unit 2, and see you in the next video.